All right, what is up, everyone? Hello, and welcome back to Nick Does Algos. In this lesson, we'll be covering the Hackerrank easy rated algorithm strange counter. Kind of a funky question. So, what's happening here? We are provided that a counter will start at the value of 3, and that is the first second. As the time increases by another second, the time will always increase by 1 second. The value will go down by 1. And we show that here. Our time equals 1, our value starts at 3, time goes up 1, value goes down 1. And then again, time goes up 1 more, value goes down 1 more until the value goes down to 1. From 1, we wind up in a scenario where we've reached the bottom. But time will continue to go on. So how would we find the next value? Well, we would take the first number in this column and multiply it by 2 and set the value equal to that. So time goes up by 1 more to find the time of 4, and value is this top value here multiplied by 2, and it goes up to 6. And then again, our time would increase down to where our value is equal to 1. Our time is equal to 9. Our next time will be 10. And what will the first value be of this next column? Well, it would be equal to 6 times 2, which is 12. And then we would count 12 down from there and add 12 to our time from there. Okay, so that's what's happening, and what should we find? Well, we are provided a t, which represents a time, and we are to return the value at that time. So if we scroll down, we see that the example input is 4. What is the value at time of 4? Well, the value at time of 4 is 6. So before we head to Replit and start to write any code, let's head over to Google Sheets and walk through some logic of what's going on. Here you can see I've basically just copied over the same logic of what's provided in the Hackerrank scenario. Clear columns and green columns. Clear columns represent time, and green columns represent the value associated with that time. And when you're looking at this, the larger it gets, the more you can see that the first time in the subsequent column will be equal to the top time plus the top value of the column before it. So we know that our value will be 2 times this value not meaning the first value in our value column, and time not meaning the first time in our time column. So we're provided that the value not of this column will be equal to the value not of this column times 2. And you can really just see through the pattern that this time not will be equal to the previous value not plus the previous time not. And here, again, you can see in this column 2, we've got 10, which is equal to this value not plus this time not, and our value of 12, which is equal to our last value not times 2, and so on and so forth. So say we are provided a value. Say we're provided a t value to find. You could see how finding the difference between a time not and the time you're provided would be valuable for finding the value at the time. So say you were provided 14. How would you find the value that occurs at time 14? Well, you could take the time not, you could identify that the closest time not to 14 is 10. You could find the difference between them, see that it is 4, and then you could take this value not that corresponds to this time not and subtract 4 from it to find 8 as your answer. Your answer would be 8. And so that's what we're going to do just in a larger scale. We're going to work with this time value of 110. And so as I just mentioned, it's a little bit easier to see here, but this time value of 14 is going to occur here because it falls between the time value of 10 and the time value of 22. You know that it's going to occur in column 2 because it is less than the time not of column 3, but it's greater than or equal to the time not of column 2. So it's within this column 2. So say this information wasn't here, and say we're working with time of 110, how would we find which column to work with? Well, we could list out our time knots and our value knots, or really just our time knots. I just need to list out our time knots until we find the 2 times that 110 occurs either at or between. And I say at because say time was 94, that would mean we would use this time 94. But we're not, we're using 110. It is less than 190 and it is greater than 94. So that means we'll be working with column 5. And the reason I bring all this up is because it's going to help us. We're going to identify our time knot using our time, and then we're going to find our value knot and find the difference between our time knot and our time and apply that to our value to find our answer. So how can we find our value knot given our time? Well, we know that we can find the column that we're working with by storing our time knot values and finding the column in which our time lands. So as I mentioned earlier, because 110 is between the first value of column 5 and column 6, we know that we're going to work with column 5. And imagine that we are keeping track of our time and we keep adding times in the manner that I indicated before. Our time knot will be equal to so our time knot here, say this is not discovered yet. Say this is all we actually have. Our first time knot is given. That's why we're going to start with our time knot. How would we find the first value? Well, we know that it's given and that it is 3. But when you start to look at all the value knots, you start to realize that there's a pattern that we can use, we can apply a counter to using our column number. And that is this mathematical pattern here. So we know that this column is equal to, B17 plus D17, right? Oh, I guess I'm trash at Google Sheets, so we just know that that is going to be 4. But how would we then find this value knot? Well, we can do it very simply using our column number that we can keep track of. And the mathematical equation that represents our value knot is 3 times 2 to the n. So we know that in our first instance, our n will be 0. And that is because 3 times 2 to the 1, or 3 times 2 to the 0 is just equal to 3. So let's increase our n by 1 and do the math there. What is 2 to the 1? 2 to the 1 is 2. 2 times 3 is 6. And then our next column, what is 3 times 2 to the 2? 2 to the 2 is 4. 3 times 4 is 12. And really, you can see that this just keeps doubling. So I'll just go ahead and fill that back out. 96. And then what's happening here? Well, it's these two values above it plus each other. So that's 10. 10 plus 12 is 22. 22 plus 24 is 46. 46 plus 48 is, what is that? That's 94, I believe. Yeah, that's 94. Okay, awesome. So that is the pattern of this chart here. That's what's going on there, and that is why we are using this mathematical equation. So imagine we are storing our time values, and we find that time 110 falls between column 5 and column 6. We have kept track of our n, so we would know that we would use n of 5. We have also kept track of our time knot, so we can find the difference between our time and our time knot, which is 16. We can then find the value knot, using our counter, because we stored that n is equal to 5, what is 2 to the 5th? I don't know off the top of my head, but 2 to the 5th times 3 gives you this value not of 96. We would then use that value not and subtract the difference we just found. 96 minus 16, our value not minus our difference, is equal to 80, and that is our answer. So that's a little visual representation of the logic of what's actually going on in this problem. Now let's head over to Replit and start to get to work on the code. So here we have it set up. Looks like I forgot to put that there, so we actually run the equation at the end, or run the function at the end. And I put some commented out notes up here just to indicate what we learned using this spreadsheet. We learned that we will work with our time knots, and our time knots will increase by the value of this little equation here. 2 raised to our counter times 3. And our counter starts, let's actually put this in another line. Counter starts at 0, goes up by 1 each column. 1 for each column. Just get that a little bit more grammatically correct. And our value knots will be equal to 2 raised to the counter times 3. So you can see that we're going to want to keep track of our time knots. We'll keep track of our time, and we'll also have a counter. So let's go ahead and initialize a counter variable and set that equal to 0. We will set our time equal to 1 because that's provided by Hackerrank. We see that the first time is equal to 1. Oh, wrong page. Time equals 1. And we should also store our time knots to find what our t falls between. Okay, and our time knots, there's actually one little thing we can do here. We can add our first time knot, which is equal to 1. And we know that because that's provided. Okay, from there, we will actually do a while loop. And our while loop will be while time is less than t, less than or equal to t. We will do a couple things. What will we do? Well, our counter will increase. We know that. We can do counter plus equals 1. But we don't want to do that first, actually. What do we want to do with our current counter variable? Well, we want to do time plus equals our 2 raised to the counter times 3. And that's because of what we know here. Time knots will increase by counter 2 raised to the counter times 3. So that's our time. That's how our time knots will increase, and that's what our time will increase by. So time at 1 plus 2 raised to 0 times 3. That means time will go to 4. We should then store that within our time knots. So time knots dot append our current time. Now let's do some printing to see what we're working with. Let's print our time. Let's print our time knots and our counter. Okay, so there you go. That's what happens for our while loop. This is what occurs while time is less than t. We know that the last occurrence, let's try to get our verbiage correct. The last occurrence in which our time is less than t is actually 94. But because of the nature of this while loop, we do the loop one more time. So we know that 110 will fall between these two. But really what we're going to work with is this last time not of 94 and our counter. But notice that our counter went up one extra time because we did this last iteration of our while loop. So that means we can actually do two things. We can set our time not, or a time not variable, equal to times not, pluck the, not the last value of our times not, we will pluck the second to last value of our times not, because that's what we actually want to work with. We want to work with this 94 because we know that 110 occurs between 94 and 190. So we will pluck the second to last item in our list. And let's just go ahead and print time not to make that clear. What did I do? Oh, I did times not, time nots. That should fix that. And there you go. We have plucked our 94 because that is the time not in which we know we want to work with. But what else did I say was wrong? I said that the counter is actually 1 too high. And that's important because we need the counter in order to find our value not, because we know we're going to need to work with our value not. But first, let's go ahead and find the difference, because we know we now have our time, our input time, as well as the time not that we're working with. So we can go ahead and set our diff equal to t minus time not. And that's really just because that's what we did here. Diff is equal to time minus our time not. We have selected our time not by using this little array manipulation. And then we have found the difference between our time and our time not. Okay, what's left? Well, we need to find our value not. And like I said, our counter is off, but we need our counter to find our value not. This is literally the equation that we can use to find our value not. But first we need to do counter is equal to counter minus 1. And that's simply because we know that we did one too many iterations of our while loop in order to find this last, the time not value that we want to work with. So let's go ahead and print our value not. And what should it be? What do we think it should be? Let's just go ahead and fix that. Well, we think it should be 96, right? Let's go back to our spreadsheet. What is 48 times 2? It's 96. That's what we should be looking here. So let's go ahead and print it. And there you go. We print the value of 96. Okay, so we have all of our variables that we need to work with established. We've got our value not and our difference. Those are the values we need to find our answer. And our answer will be value not minus our difference. We can set that equal as a variable, and then we can go ahead and print our answer. And there you go. We print our answer of 80. So this should work. Let's go ahead and copy and paste it over into Hackerrank. Let's paste it correctly. That should be fine. Let's get rid of all these prints. We don't need those, and change this print to a return. And let's give it a run. Awesome. We passed both of our sample test cases. Go ahead and test it against all of our test cases, and we get a nice quick pass of each one of those. So there you go. I hope that makes sense. You could consolidate this a little bit. You could fit all of these lines of code into a couple less lines of code if you really wanted to. But I just wanted to be clear of what we were doing by setting each variable equal to something specific to follow that logic that we established over here in our Google Sheet. So I hope it helped. I hope it's clear. If you have any questions at all, please feel free to drop them down in the comments below. If you like this video, if it helped you out, please go ahead and hit the like button. We post new algorithms just about any given day. So if you are currently covering algorithms, if that's where you're at in your career, you're preparing for interviews or anything like that, go ahead and hit the subscribe button. I'm sure we'll be able to help you out again sometime in the future. Thanks so much for watching, and we'll see you in the next one.